just to start with an outline there, what we're going to cover. We're just going to have a quick intro there, go over the contents, a bit of justification, what we're talking about, why it's interesting to you maybe, and then we're going to kind of go through an overview of the components that make up my little system. Then yeah, we'll have a quick summary and maybe time for questions, depending how I manage. So the diagram there is just to give us a bit of a context and overview for the whole system. So we basically have just a kind of Raspberry Pi server and a bunch of MicroPython microcontrollers with sensors, and then some kind of client devices like just my phone and the BMO device there we'll talk about later, and some smart socket controllers there, the sort of weird white looking yoke. Just a reminder before we get into it, naming is hard. So, I mean, some of the naming here is just components of open source stuff, and then some of the weirder things are my own naming, and I'll try to explain why I picked those names as I go through it. So yeah, a bit about me first of all. Max, I'm a systems reliability engineer at Demonware, where I kind of manage and maintain the authentication and user accounts systems for the Call of Duty game servers. We operate, these are Python web services for the most part, but I'm more interested in kind of automating and maintaining and looking after the system, so I mostly just use Python for kind of basic scripting and glue scripting. Yeah, I'm originally from Cork. For those who don't know, it's the biggest and best county in Ireland, and we all take every opportunity to remind everyone about that fact, an undisputable fact, you know, and it's often considered to be the real capital of Ireland. But yeah, okay, moving on from the controversial topics, just Cork's great. Give it a visit sometime if you've never been. Yeah, then otherwise, my first Python version was 2.5, and I mean, I think that's just kind of interesting because, right, we have a very diverse and varied group here, and people have, you know, using Python for all sorts of different use cases, and I think maybe that's why this is a bit interesting. It's a slightly unusual compared to kind of the normal data science or maybe web server development stuff that we see a lot of, you know. And yeah, so I mean, I was basically in secondary school trying to decide what I wanted to study at university, and I was considering a games development course in University of Limerick, so I thought, oh, I better kind of figure out what this programming stuff is and, you know, learn a bit about it before I decide. So I just kind of tried some online web course in Python and just used that and promptly forgot about it, and we learned Java, mostly object-oriented Java in university. In 2011, I was accepted into an internship at Demonware, and I decided to go to PyCon Ireland in 2011. So yeah, it's taken me kind of 11 years to pluck up the courage to give a talk here, so that might give you an idea. But yeah, I've attended pretty much every year since, and it's really great to be back, and it's a brilliant conference. It's been great to kind of see it grow year on year and see, I mean, even to see the data science and machine learning has really come on. Like I seem to remember at that first conference, you know, someone kind of introducing Jupyter Notebook as like a kind of new cool thing, you know. So yeah, it's been interesting. Yeah, what else? Yeah, I think it was just clear to me early on that there's something a bit different about Python and the Python community, and it was kind of a bit special, and from that point on I kind of lent into Python quite hard. And for the context for this talk, in that picture there, that's the obligatory me with my keys. I was lucky enough to be able to buy a house in late 2019. Unfortunately, it wasn't in Cork. I couldn't afford it. Somehow word got out that Cork is great, and the market there was just worse. It was mad. But anyway, so why this talk, and kind of why is it interesting, and what are we talking about? I suppose the title's a bit vague and mysterious, and maybe it sounds a bit more complex than it actually is, right? What we're actually talking about is my sort of hacky little implementation for controlling my boiler and heating system and taking some metrics of the house and garden, you know, a bit. But it's maybe just a little bit interesting to talk about. You know, you might find some of you probably haven't heard of MicroPython before, and we'll go over some open source kind of tech that you might be interested to learn about too, or some of you may be very familiar with. And yeah, it's a kind of a slightly unusual use case for Python, right? I mean, an interpreted language as on embedded systems and microcontrollers, like, seems pretty insane to people, and people from a kind of C background would wonder, like, why would you bother, you know? But yeah, it might give you some ideas. It might inspire some of you to kind of dust off that Raspberry Pi or that microcontroller you have kicking around somewhere at home and get stuck in with MicroPython. So the picture there is just a jack-o'-lantern I carved this year just to celebrate the launch of Modern Warfare 2, which I've been working hard on for the last year. And of course, you know, I had to put a microcontroller in it and use Python in there just to control the colored LEDs, right? Yeah, so I've been kind of playing around with MicroPython for a good few years now. First heard about it at the 2016 Lightning Talks at PyCon. Shout out to Sean O'Donnell. I'm not sure if he's here today, but he first, you know, should introduce me to it. Then I've been running the same workshop I ran this morning. I've run that a few years now at PyCon and at PyLadies and at a few universities as well. So, you know, I had these controllers sticking around at home, kind of doing nothing. So I bought a house, right? And like a good SRE, I kind of said to myself, right, how can I automate this? That's what you got to do. And pretty quickly I had a kind of problem looking for my solution, you know. I was trying to, you know, it was early 2020 and wasn't moving in yet, but events were kind of rapidly coming to a head, and I kind of started to realize I needed to accelerate moving into the house. It was mostly unfinished in the interior and hadn't been lived in for quite some time, so I was trying to get the heating working and the boiler and everything, and I had a guy out to service the boiler, and you know, the problem, there was a bird's nest in the flue, like, was the thing he pulled out of it, like, and of course, you know, he got that all working great, perfect, and then next thing, straight away, the controller falls apart in my hand. You know, it's like this cheap plastic mechanical timing unit there on the right, you can see, and it just like fell apart, and I was like, okay, great, the boiler's working, but I can't turn it on. And yeah, at this time it was getting pretty difficult to get hold of tradespeople, or, you know. So I had these controllers kicking around. I thought, why not just implement this myself with MicroPython and the few boards and see what happens. You know, and learn about it, an opportunity to learn more about it and find an application for this. Sure, there's other kind of there's other frameworks in OpenHab and existing open source projects that you can use for this type of problem, but, you know, like anyone, I just want to try and implement it myself and pay the price. Is it cheaper? Was it cheaper? For the actual control unit, I just was looking at it there, and the unit cost of what I used, and we'll look at later on, for the actual boiler controller was about a tenner, like €10 for these components. And I had a quick look on Amazon there, and, you know, the equivalent thing that you'd buy online is, you know, €50 minimum. So it actually was cheaper in terms of the base hardware and components, which is kind of mad. But obviously the time spent messing around with it and playing and everything is probably a lot more expensive. Okay, so just introducing MicroPython, what is it? It was first kickstarted in 2013 by Damien George, and it's, for all intents and purposes, a fully functioning implementation of Python designed for running on embedded systems and microcontrollers. Since then, the project has really grown and taken off, and there's all sorts of forks like Adafruit's CircuitPython, and, you know, they've ported it to all sorts of different platforms. And just 2 days ago, actually, it was announced that Arduino are going to have some experimental support for it on some of their hardware platforms. So that's pretty exciting if you're into Arduino. So yeah, will this actually work? Kind of looks like it's loading. This was struggling to load earlier. This was the first thing I kind of tried with MicroPython. I had implemented this sort of foosball score tracker thing for this foosball table at work on Arduino, and so I just transposed it to MicroPython and thought it'd be kind of interesting to compare and contrast, you know. And straight away it was much easier to be able to develop and iterate on the REPL compared to compiled Arduino C++, you know. And for my own sake, it was just sort of a learning opportunity for soldering and hardware design. I'm not sure, is that GIF actually playing there, or was it? It's effectively, I'm just building a controller for this 8-segment display, just as a challenge for myself, isn't it? Driver thing, it's not very interesting. Oh yeah, that was the second one. Okay. So then MQTT is one of the main Internet of Things protocols that we use for kind of controlling these devices. So I hadn't heard of that before, and I just looked it up. I mean, like, okay, if I'm going to be doing messaging between distributed microcontrollers, what do you want to be using? And MQTT is basically the standard of the day. It's open source, it's simple, it's lightweight, it's very, very well suited to memory constrained environments like a microcontroller. And it has kind of cool features like reliability and quality of service options. And because it's a standard, right, you could integrate with other platforms, OpenHAB, these things. And there's loads of services available free or otherwise, like AWS have MQTT support, and Adafruit have a pretty cool, just free tier MQTT broker service. The broker basically being at the server component, right, that kind of controls the published and subscribed clients. We don't really need to know much more about it than that. Essentially, you have multiple clients, and they can either subscribe or publish a given topic. A topic is just a / delimited hierarchical naming system, so that then clients can subscribe to sort of everything in a given namespace. You could start. We'll see later in the code examples, but yeah. So running through it quite quickly, but just to introduce these topics. Graphite is the metrics kind of platform that I used for this. It's an open source Python-based metrics application. Many people may be familiar with it. I was already using it at work, right, so I was relatively familiar with it, and it was easy to install on a Raspberry Pi. Maybe not so easy to configure, as I found out the hard way, but it's made of a few components. It's not too interesting really there, but just like Carbon is the file store that actually manages the time series data as files, and then Graphite Web is the actual Django web application for kind of interacting with it, right? So managing the storage format and the retention of the Whisper files is tricky. The default retention that it comes with is like 24 hours and your data's gone. So that caught me out a few times initially when I was testing it out. And then while writing the slides for this, I went to try and capture photos of my old metrics, and discovered that in fact I've lost all data beyond 30 days because my roll-up was misconfigured, or it was rolling up the null values, and so I've basically lost all my data older than 30 days. Oh well. Maybe I would suggest there are services like Hosted Graphite, previous sponsors of PyCon Ireland, out there, who just host Graphite as a service for you and take care of those hard problems. And there's also loads of different there's a whole ecosystem now, and you can get different backends or different things to go behind the Graphite interface. I think ClickHouse is one example of just something that uses the Graphite API but has its own storage format. So yeah, it's kind of interesting if you're, if you ever want to dive into metrics and graphing system and be able to read the Python source code. Graphite's a pretty good one for that. So here's just an example of the, a kind of default Graphite rendered graph. This shows the first night that I spent in the house. Not sure if you can see, but it was pretty much 15 degrees at most during the night, which sounds relatively comfortable, but believe me, it was absolutely not. And yeah, until the fabric of the house heats up, you'd be surprised at just how cold a place can be. So yeah, I mean, it's a little bit basic, right? I mean, okay, there's more options for the render API. I've done a very minimal job there, but Graphite by default doesn't maybe give you the nicest, interactive or kind of nice graphs. So, this was it. The initial, I kind of had an initial proof of concept when I first moved in, just to track what the house was like at the time. So instead, enter Grafana, which I'm sure many more of you are probably familiar with as a platform for kind of visualizing data from different data sources. It's just a lot prettier essentially, and it has a really nice web interface for kind of visualizing just discrete data sources, and you can build and share dashboards, and there's a user management system, and it's just a lot more kind of user friendly and nice, and there's tons of integrations and different plugins and cool visualizations and geo maps and all sorts of cool stuff. But for my use case, I just wanted a simple dashboard that I could use to draw my data, and it supports annotations is one kind of nice feature there you can see. So if you can see, the graph is a bit hard to see there, but essentially we just have a bunch of different rooms in the house measuring the temperature of it, and then there's a blue dashed line there in the middle which is annotating when the boiler was turned on through the system. And then you can kind of see there's a nice uptick in the measurements there for some of the rooms. I guess the rooms where the sensor is closer to the radiator basically. Again, I was kind of familiar with it. It's relatively easy to install on Raspberry Pi, and yeah, seems like a pretty nice system. So the microcontroller platform that I've used here is the ESP8266. So that is a very popular and quite cheap Wi-Fi capable embedded device. It was originally quite obscure, and there was no like English documentation for it, and it was just this like cool cheap chip from China that a lot of makers and people started using. And then as it gained popularity and it started to be used, it's used in tons of cheap IoT devices now. If you buy a smart light bulb or a smart socket, decent chance it's an ESP8266 in there. But yeah, the maker community jumped on it, and somebody ported it to MicroPython. Specifically, I'm using this this Lolin WeMOS one. It's just a particular platform. The chip itself is obviously just a small embedded chip, and you need some kind of extra components to make it usable in an environment like this. Just particularly something to handle the USB to UART translation there, so that you can just plug it in and program it right. But obviously, in a real industrial environment, it's going to be built onto a discrete chip or platform. I like these guys. It's the same one that Sean O'Donnell showed at the Lightning Talks long ago, and since then I've just liked that manufacturer. They're kind of open source their hardware designs, and they've iterated on their chips, and they have lots of cool little sensors and different kind of screens and things to play with, and they use stacking headers, so you can just like stack these things together. So I've always found them quite good, but obviously there's tons of other different options out there. Adafruit are quite a good beginner's one as well, for example. So yeah, a quick look at the tech specs there. Interestingly, it's about 80 megahertz clock speed. It's got about 80 kilobytes of user RAM, and generally there's about 4 mega flash attached to it, program flash, for actually like file storage, which is really pretty limited when you think about it. And like looking back, that's actually pretty much the same spec as my first ever computer there in the early 90s. So a home PC of the early 90s is now, this chip costs less than €1, and it's got pretty much the equivalent computing power there. So you can kind of start to see how we're able to have interpreted languages now on these cheap embedded devices, because Moore's law happened, right? And we just have so much power and space available. So, okay, I didn't want to put too much code into this, but just kind of to give you an idea. By default, when MicroPython boots on a device, it first looks for a file boot.py and then a file main.py, and then it'll enter just the standard REPL if those programs aren't stuck in execution, right? I'm not sure how legible that is for you, but on the left I have an example of the boot.py file I use, and essentially we just import some standard libraries and then attempt to connect to the Wi-Fi network from the configured network, right? This is the standard one I use on all of my little projects or different things, and you'll see I actually do eventually continue even if we couldn't connect to the Wi-Fi, because for a given project you might need to. Then we have the main.py. Again, is something, a kind of template I just use across multiple projects. it's pretty simple. We just import some machine functions. That initial sleep 3 is just a time for you to interrupt the main program. So if I need to program it or make changes or debug it in the REPL, I need time to actually just be able to connect it, Control C, then kill the execution and get an environment on there, which is a bit of a hack, right? If you were doing a kind of proper production system, you don't need that, obviously. But that's handy. And then I'll just try import my main project, whichever the project module is for the environment. In this case, nvon is the metrics one we'll look at in a bit. And then, yeah, catch all exceptions. You know, bad idea in most contexts, but in an embedded environment, you may not care, or, you know, I'm just interested, try run the application. If there's exception, fine, and then just carry on, and it goes into a deep sleep for 5 minutes just to save power, and then it'll just keep iterating like that. The first component in my little bit is Castor. So this was a replacement for the broken boiler part that I showed you on the right there. It's just three relays, one for each rad loop and one for the boiler itself. A relay is just a switching device that will allow you to switch a higher voltage and current device with a low microcontroller type voltage and current, right? It's pretty simple. It just subscribes to the MQTT topic for my control messages, and then based on that, it'll turn on or off the individual loops, right? So yeah, I just kind of needed this quickly as a replacement for that controller, and you can see now the before and after. It's all very fancy. Now it looks a lot better. You can just, those 3 blue bits are the relays, and then the little bit of green you can see underneath at the bottom is the actual controller itself. Obviously there's a lid for closing that enclosure as well, and I had a professional electrician do the household mains bits, don't worry. Yeah, so why is it named Castor, right? That's a pretty weird name. So I don't know if some of you may remember Disney's Tron Legacy. There was this character, he's sort of like a weird budget open source David Bowie sort of character, and he has the Ubuntu logo sort of watermarked on his forehead for some reason, I don't know, but essentially he kind of controlled the input and output in the Tron Legacy world, right? And I was looking for some kind of name for control, and that was kind of cool, or stuck in my head, I don't know. It's pretty memorable in fairness. So looking at the code, I mean, this is a simplification, but essentially we just have 3 basic input-output pins, one each for the bedroom loop, the living room rad loop, and one for the boiler. And then we have a function which is the subscription callback. So it's not actually shown there, but you know, elsewhere at the start of the program, we subscribe to the Castor star plus all Castor topic messages essentially. So we subscribe to that, and then if a message gets published on that topic, this callback will be executed, and it takes in the topic, the message, the content of the message, and then this retained flag, which is just something to show if the message was stored by the server while we were asleep. And then, yeah, like very brute force, just, you know, if-else statement match on the topic name, and then turn on or off the individual boiler loops. We also store some tag data for sending to the Grafana annotations. And then at the end there, you can see we send that, I call it a Graphite event there, but it's technically a Grafana annotation. And then for the publishing loop, we just loop over, like this is basically the main execution flow of the program. We just loop over that publishing queue until there's messages there. And if they are there, pop them off, publish them back to the broker, and then sleep again. So nvmon then is just the kind of temperature sensor monitoring device. In the photo on the right, you can just see there's the microcontroller, and then that little unit on the right is the SHT30. It's just a temperature sensor, essentially, quite accurate. And again, the code is pretty simplistic, right? Import a bunch of configuration and standard library stuff. Define the kind of metric timestamp message format, and then just go in, take the temperature readings from the sensor, format the messages for sending to Graphite, and then at the end open a socket to the Carbon endpoint and publish your messages, right? Everything in the queue. Not pictured. There's a bunch of other optional sensors or things that I have integrated for different versions of it, but this is the most simple one, the one for the temperature and humidity. Right, so then the actual kind of control loop at the moment is just crontab on the Raspberry Pi. So I manage and turn on and off the boiler loops on timed loops just using good old-fashioned crontab. If you're not familiar with crontab, it's just a standard like Unix, Linux tool for executing programs on a timed or scheduled basis. And the format there is kind of these, minutes, hours, day of month, day of week, is it? Day of year? I forget. Anyway, wherever it's, so you can see here in the morning, I basically, at 6 o'clock in the morning, turn everything on. At 6:30, turn off the boiler. There's a bit of a weird thing here where the bedroom and boiler loop are switched in the naming, so I just, for now, bedrooms is boiler and boilers is bedroom, don't worry about it. And then, yeah, same thing, later at night, turn it on for half an hour, turn it off, that kind of thing. It's simple and stupid, but it works and it's reliable. I mean, how old is crontab now? It's like early 70s or something. It's nearly 50 years old or something. I was musing, it's probably nearly as old as those electromechanical timer things that it replaced in the first place. So it's not like fancy new technology really on the scale of things. So I mean, some of you are probably thinking like, wait, what? This automation is just a cron job? Yeah, well, it always has been, right? That's pretty much it. Like, you'd be surprised at what in production environments today it's just a cron job. And Kubernetes cron jobs are not great, shall we say. Then another one was kind of Gardermoen, as I call it. It's just a slight adaptation of the nvmon script, specifically for temperature sensing outside. I have a couple of extra sensors for soil monitoring, light sensors, 3D printed Stevenson screen. That white thing is just to keep the direct sunlight off the sensors so the temperature readings aren't completely ruined by that. And this one needs an external Wi-Fi antenna just to be able to reach the network on the house, right? This is in the polytunnel. And yeah, it's quite useful to accurately have soil and air temperature readings, and helps me determine when to actually plant out the tomatoes or plant out the melons. Like, if, once the soil temperature reaches 12 degrees, you can plant stuff out. But otherwise, you're just sort of humming and hawing and guessing based on, arbitrary things. So yeah, I guess in the future, I'd probably like to add some extra control and maybe be able to turn on the drip lines or water, or open and close the doors for ventilation and stuff. But that's a stretch goal. And yeah, briefly as well, we have these Sonoff socket devices that just a cheap IoT socket device you can buy online. And where have we gone? Sorry. Oh, surprise, surprise. It's an ESP8266 inside. So I can just pop off the cover, solder on some wires, and then flash MicroPython onto it myself, and away I go. And again, just a very simple little control loop, subscribe to the control topic for the socket thing, and then when you get a message, turn on or off the socket. Briefly as well, there's this graphics library then that I use for kind of controlling the user interface for one of these things. LVGL is quite a nice little embedded graphics library, and it has support for MicroPython as well, which is pretty handy. It runs on an ESP32. The ESP8266 is too hardware constrained. It does not have enough memory for the screen that I'm using. Just the buffer of all of the pixels that I use would fill the memory on the ESP8266, right? So you need something beefier for that. If you ever want to build a kind of embedded UI for anything like that, it's a pretty sweet library. Check it out. And so BMO is what I'm finally getting around to building as an actual client interface and controller for this. Some of you might know the BMO character from Adventure Time. I'm basing it on that and 3D printing a sort of enclosure. It's going to talk, and I'm using a sound chip so that it can talk and execute commands, and then otherwise it's just going to send control messages to MQTT and maybe display metrics and graphs based on the temperature sensors. Still working on that, honestly. It's a bit slow going, but it's pretty fun. Oh yeah, just to show you the little kind of menus, work in progress stuff. So it's a touch screen there, so you can just build a little button interface on the touch screen. MicroPython is pretty sweet. It's kind of cool. Check it out if you haven't before, and even just go and read the docs on micropython.org or kind of see what's out there, what people have done. I find it much more usable than the Arduino environment personally, but that may vary. I suppose it's kind of interesting. You can build, generally speaking, you can build relatively complex systems from quite simple parts. I think hopefully each of the scripts I've shown you today are, really quite straightforward little, not very intelligent or well implemented scripts, but together they actually build up something useful and meaningful. And this is how I've been running my heating system for 2 years, and okay, it's kind of hacky and ugly, but it works and it does the job. And sometimes just it's better to just get stuck in and build something, and it works and iterates from there, right? I mean, MVP of sorts. And yeah, hopefully now you kind of understand a bit more from that diagram and kind of what each component is and why it's there. Yeah, carbon metrics rollup is hard. Yeah, I'm going to have to go and look at my metrics and try and see if I can save any data there and fix that. Maybe just get hosted Graphite for yourself or use an external service for metrics instead. Lots of modern alternatives now, but Graphite was the answer for a long time. And yeah, just acknowledgements, just shout out to all of the people behind the MicroPython project. It's awesome. Thanks to my sister who helped me with this talk and gave me some feedback when I trialed it with her. And yeah, the Python Ireland organizers and staff and volunteers and everyone here today. Just thanks very much for having such a great conference.
Hey, thanks for your talk. I have actually one question. So when it's summertime, how do you deal with the crontab? Do you just go there and comment, or just keep the boiler on all the time?
For now, no. For now, I'm just
go there and comment.
I'm just manually changing the crontab when I need to. But yeah, I mean that's right. That brings up the whole point. Really, what the system should be, I think, is more that the Castor component should subscribe to the metrics from the temperature sensors and then make slightly smarter decisions based on the temperature whether the boiler should engage, right? Like it should just say, okay, is the temperature less than threshold 17 degrees, whatever we define as comfortable, and set it on that. And that would be the plan longer term when I get around to it, is make it a bit smarter. Yeah.
Yeah, thanks. That actually, next steps would be something like that, right?
Yeah, exactly. So, I mean, I think that's it. I've kind of shown the building blocks and what's there and what you can build from there. And now I guess I have to go away and implement a lot more myself.
Cool. Anyone else?
Good talk. Thank you very much. Do you expose any of that for yourself externally outside of your house? And how do you make sure people don't start turning on and off your boiler randomly?
Yeah, no, exactly. Good question. No, the entire thing is self-contained within the house. It's an access point Wi-Fi on the Raspberry Pi, and it's all just contained. So yeah, that was something I considered and was concerned about. You can, of course, secure. There's authentication for MQTT and all the protocols involved. And I did experiment with using external brokers and external, I hosted Graphite, for example, as well, if you wanted to. But I wanted to make the system independent of the internet access and fully independent. And yeah, I mean, if you're close enough to get Wi-Fi signal, then you're on my property already. So, I mean, yeah.
Cool. We have time for one more question, if anyone has it.
Great, okay, thank you very much. So just a quick question about the boiler automation there. With the hardware that's currently in place, is it possible to get the feedback from the system, or do you have to install additional stuff, like whether the boiler is actually turned on, or do you just send a signal and hope that it's going to turn on?
Oh, yeah, it confirms, it sends a results MQTT message to confirm that it has switched on that loop, exactly. So there is feedback from the device in that sense. I mean, I guess I'm relying on, I don't know, electricity or the boiler loops to behave correctly when they're switched manually. But I mean, that's the same as any electrical boiling control system. So, yeah, it would be kind of nice maybe to get some more advanced feedback there, or even just be able to like correlate temperature metrics or some kind of way to confirm that. But for now, it's just the device itself confirms that, okay, I switched that input.
Thanks.
Thanks.
Cool, great stuff. Thanks again, Max.